So in these problems, these are really probabilities. We can also think of these as probabilities of populations. Okay. So and what I mean by that is there is a finite amount of events that can occur. We have a sample, we're not talking about the sample, we're really talking about the entire population. So there might be, for example, 15, so i.e., there might be 15 students. There might be 10 shirts, and you're seeing your homework. There might be, 20 or 20 animals, pets. And the idea here is you're selecting from these, and the students might be like male or female. You might have small, medium, large. You might have a cat or a dog, for example, right here. And you're going to select from these. All right. Now, in each one of these, they're all mutually exclusive as well within each one of them. So you have either a cat or a dog, but you're going to select them. And the other key information here is that this idea of without replacement. And if you remember in simulations, it meant we ignored repeats. And in actuality, what happened here was that you had less to select from. So there's always this idea of every single time you select something, there's less to select. So I don't want to do this one right now. Hold on real quick. Yeah. So if you remember, in terms of probability, the idea here is the number of occurrences interested in number of occurrence we want to have over the total possible occurrences. So in a basic example of one selection, and so remember, we're talking about without replacement. And now sometimes in the problems, it'll specifically say without replacements, and other times it's inferred. In other words, you kind of know that that's the case. Now, let's say in this example, I have 22 AP Stat students. Well, actually, let's go 17 AP Stat students. So that's my population. That's my who. All right. Of these 17, I have 11 females and 6 males. And I'm going to select them, the students. So the questions are pretty, the first initial questions are old material, which doesn't matter, it's selecting one. So if I said, for example, and this is basic middle school, ninth grade type of stuff, what is the probability I select a male? Okay, so we did this almost on the very first day that we did probability. What's the chance I select a male? I select one student. What's the chance that it's a male? No, 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 no. You don't. And remember, I first and foremost, I do not want specific answers with decimals. We need to show our work. So showing the work is far more important. This is a perfect instance where showing the work is far, far more important. The answer is 6. Yes, 6 over 17. The probability that I select a male is 6 over 17. I don't care that what the decimal is really, unless it's a multiple choice question where I have to look it up. I'm just going to keep it at 6 over 17. So that's the answer. The probability of selecting a male is 6 out of 17. Okay. And if I wanted to select a female, what's the probability that I select a female? 11 out of 17. Okay, boom. So in the selection of just one individual, it's normal probability. I mean, that's kind of like the questions that you had before. Now, in my other questions that we did, we had we had with replacement. So without replacement, and so here's the main premise. When making multiple event selections without replacement, the denominator always decreases by 1 for each follow-up selection. So after I've selected my first one and I say, okay, now I want to select another student. How many students are there left now when I make my second selection? Can't pick the same person twice. So what that replacement means like I can't pick the same person twice. So how many students are there now to select from after I've selected a student already? I selected a student. Now how many students are there left to select from? Yeah, 16. 16. There's 16 students to select from. There was 17 students initially, there's 16. Now, I select another student. How many students are there to select from now? For my third one, when I make my third selection, how many? There's 15. And it goes on. So the denominator will always always decrease by 1, no matter what, because there's one less student. The numerator will only decrease if making the same selection. And so the premise here is like a tree diagram. And so what I mean by that is that when I made a selection, I could have selected a male or I could have selected a female. The probability of selecting a male was 6 out of 17, which is a probability, and the chance of selecting a female was 11 over 17. Now, we often refer to this because without replacement, we usually put a little ones in terms of my first selections and twos for my follow-up second selections and so forth. So I want to choose a male as my second, or I can choose a female as my second. Those are my two options. So this isn't like coin flipping, because coin flipping is infinite. There's not a set number of outcomes that can happen there, not a finite population. I can select a male on my second or a female on my second. Now, in each of these probabilities, the denominator is now 16 because there's only 16 students left to choose from. So, given that I selected a male already, what's the chance? How many males are there left? How many males are there to select after I've selected one of the males? I selected a male. How many males are there left? Started off with 6. 5. Perfect. So the chance of selecting a male is 5 out of 6. Now, what we're saying here with this, so when I'll put it up. What we're saying here is that the probability of selecting a male given on my second choice, given that I've already selected a male, is 5 out of 16. How many females are there after I've selected a male? How many females are there when I make my second selection? If the first selection was a male. There's still 11. There's still 11 females. I haven't selected a female, so the probability of selecting a female on my second choice given a male was 11 out of 16. What's the chance that I select a male for my second selection given I selected a female already? How many males are there remaining after I've selected a female? Start off with 6 males, 11 females. I selected a female. How many males do I have left? Yeah, I have 6. I have 6 males still. I haven't selected any males. I started off with 6 males. I still have 6 males because I only selected a female out of there. So the females is going to decrease. So I get 6 out of 16. So the probability I select a female second, given that I selected a female already, I already selected a female. How many females are there when I make my next selection? Ten. So to note here, this went from 6 to 5 because a male already selected. This stayed 11 because a female wasn't selected. This stayed 6 because a male wasn't already selected. Put the already. And the last one down there was 10 out of 16. That went from 11 down to 10 because a female already selected. Now, I'm not asking you to make these tree diagrams, but hopefully the connection that we've made in doing tree diagrams before makes some sense, because most of the times in these problems, we're going to select multiple students. So question C. Now, if I asked you, what's the probability of selecting a female, given that I've already selected a female, okay, those are rarely going to be the questions. So if I asked you, question C, what's the probability of selecting a male the second try, given male selected first try? So sometimes they ask this question. So you need to convert this, say, oh, they're asking me what's the probability of male given male. But I also know that this is finite. So I know I have to treat these as different. And so I've already selected a male. So now there's going to be 5 males because I've already selected a male. and now I know there's only 16 because it went from 17 to 16 students the second time. That question does happen. Okay, I have seen it. They ask you for that conditional probability specifically, but that's not really the main question, and I don't think you're going to see that question in tonight's homework. What is going to be asked is these questions. So this is pretty much the main questions that I'm really interested in. So what is the probability that two males are selected in a row without replacement? Now remember, I'm just reminding you, this is without replacement. So that means my denominator must change. Technically, this is asking you what's the probability I select a male in my first try and I select a male in my second try. These problems are or I can say and a male in my second one. These problems are much easier just done as to keep them as fractions. Okay. And remember the property that the denominator has to go down. And we know if we're doing the same thing twice, then the male has to go down. So going back to the question I've already asked you, what's the chance I select a male the first time? So it's 2 times. But remember, we're multiplying. So what's the chance I pick a male in my first one? You've already answered it. As a reminder, 17 students, 11 females, 6 males. What's the chance that I pick a male the first time? That's not a probability. 6 out of 17. 6 over 17. All right. What's the probability I select a male on my second one, given I already selected a male on the first one? All right, how many males do I have left now? I've selected a male. I automatically know in every one of these problems, the denominator has to go smaller. Okay, that's the good thing. I already know the denominator has to get smaller every single time. So on all these problems, because there's one less person. Now the question is, what's the chance that I select a male that next time? And it's not 6. No. Oh, you haven't answered. That's looking at the answer. Kind of blinked at that. I saw something there. We've already answered it. We already have it up there. But just thinking about it, yeah, it's 5. No, it's not out of 17. It's not out of 17. It's 5 out of 16. Okay? So the whole premise of this lesson is on this idea. The first one is a no-brainer. All right? 6 out of 17 should be a no-brainer. Nobody should have problems with that one. Period. If you're not, if you are, if you're asking me why it's 6 out of 17, I'll be very blunt, drop the class. All right? That's the 6 out of 17. All right? I'm very blunt about that because there's 6 males, 17 students. It's the easy, most straightforward thing that happens. The first male, 6 out of 17. Has nothing to do with almost AP calculus. It's just normal things you've been probably doing since elementary school. I have 6 red marbles, and there's a total of 17 marbles. The chance of selecting a red marble is 6 out of 17. Nothing changed. What is new, what might be a struggle with this first time, is the next one. First off, understanding it's a multiplication problem. That's a AP statistics concept or a statistics concept. When I want to find the probability of 2 things are selected, it's an and. Ands are multiplication. And that second one, because they're not independent, so it's not going to be 6 out of 17 again. All right? It's not like the previous problems where I just say, oh, that's 6 over 17 squared. No. Some of you are going to go 6 over 17 squared. It's going to be 100% wrong. None of your answers tonight especially will look like that. So now there's one less male because I've already selected a male, so it goes from 6 to 5. And the denominator always decreases because I always have one less student. I've taken out a student from the equation. I can no longer select that male student. All right. That first student was Joshua. I selected Joshua. Now Joshua can no longer be selected. So now there are only 5 other male students within the class, and since Joshua has already been selected, there's only 16 students within the class to select from. That's the concept. Now, in AP Stats, that's the answer. Of course, that on the AP exam, you could multiply these out, or you can just do, calculations, and I multiply these together. 6 times 5. So this technically gives me 30 out of 17 times 16, 272. 30 divided by 272. So I get 0.11. It could occur that this is a multiple choice question. However, most of the times I've seen this question on the AP exam, they actually show out the work with fractions to help you out. And you go, oh, it's one of those fraction problems. Okay, I just multiply top times top, bottom times bottom to get my work. If you have a calculator, Desmos, the calculator app, I would like you to do the decimal answer to make sure that you're doing it correctly. All right, E. This is a new one. So what is the probability that the 4th student selected is the first male? Okay, now we got to think a little bit more conceptually here. Can someone explain what this means? What happened? What must have occurred? Can somebody re-explain to me what it means? The 4th student is the first male. We've answered this question before. We had to remember that those blood type problems. You might even had a male-female type of question. The 4th student is the first male. What does that mean about the others?
They're all female.
What do you mean by all? Can you just clarify that really specifically, a little bit more specifically?
Like the first 3 of them will be females or something.
Yeah, bam. So what this means in terms of interpretation is that the first 3 were female and then male. Now we can write this as the probability of a female and a female and a female and then a male. Now, order is important on this one. So the reason why I use these numbers on the bottom they are numbered because order matters. Okay, the order of which they're selected does matter. So that's why I put the 1, 2, 3. Now it's an and, so it's still multiplication. So my answer here is something times something times something times something. All right, the first one is the easiest one. It's a female. The first one is a female. So I see Soraya's part. She asked, you found the probability of a male given that the first 3 were females. All right, so you found the conditional one. You found that what Soraya has found is she found that the last one is going to be 6 out of 13. But this one's asking you for the whole outcome. Now, there are questions that will ask you that will state something like, the first 3 students were female. What's the probability that the next student is male? Now, that is the 6 over 13. Okay, because it's only asking you the probability of that one outcome happening. But these are 4 different outcomes. So the first probability is a female. What's the probability my first student is a female? As easy as it gets, people. Don't overthink the first one. The first one is, oh, duh. 11 females out of 17 students. That first one is a give me. The first one is the freebie for you. All right? Not much lesson in terms of nothing much that doesn't really depend on anything I've taught you so far. That first selection is the one that you should be like, of course it is. Now is where the tricky things come. What's my female for my second one?
Is it 11 out of 16?
Close. That's a question mark. I want answers. I believe.
10 out of 16.
It is 10 out of 16. There is one less female now. Now the bottoms, or you can fill out the bottoms if you want to. You can fill out the bottoms. And it actually turned out it wasn't over 13. It was going to be over 14. That's why you should just do it all the way out for that last one. All right, the next one is another female. So how many females are there now? So it's female. It went down 1 because I was selecting another female. And then now I'm going to select another female. So it goes down again. So now it is
9
out of 15. Perfect. And then it's male. So this is female 1, female 2, female 3, and now the male. How many male? What's the probability of what is that?
Is it 6 out of 14?
6 out of 14. Pulling up my calculator app over here. Go scientific. All right, so that's my answer, which gives me, let me see, parentheses, 11 over 17, close parentheses, open parentheses, 10 divided by 16, close parentheses, open parentheses, 9 divided by 15, close parentheses, parentheses, 6 divided by 14, close parentheses, enter. No. Okay, I am not good on these calculators. 11 divided by 17, close parentheses, times, hey. I wish I just had my graphing calculator, which I don't have on me right now. Times, parentheses, 10 divided by 16, times 9 divided by 15, times 6 divided by 14. I got 0.104. Can anybody confirm that? I don't know where my calculator is at the moment. Did anybody get the same thing? Did anybody get anything different?
I got the same things.
Perfect. And our final type of problem, which we've already done. What is the probability? So we're going to select 4 students. What is the probability that at least one is male? Okay, I'm going to select 4 students, and I want to know what's the chance that at least one of them is male. Now, there's 4 students, so there's all kinds of different outcomes that can happen. And we've created these tree diagrams and instances. It could have been male, 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 female, male, 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 female. There's so many male, there's all these different outcomes at work that I'm like, okay, that's good, that's good, that's good, that's good. But then there's one instance that is not work. Female, 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 female. And this is the only instance that doesn't include at least one male. All right, let's see how good our memory is on this material. How do I find the answer? Not what's the answer. I know there's 2 to the 4. There's so many different possibilities that I could happen. In this case, there are 16 different possibilities. 15 of them would count as having at least one male. Could have one male. The male could be the first one, the second one, the third one, the fourth one. There's 2 males. The 2 males can be broken up in many different ways as well. There's 3 males. There's 4 males. And of course, the order can happen in many different ways. Those all work, but there's only one instance that doesn't. And as such, the probability of at least, for n equals 4, of at least one male is equal to, can anybody recall what I do? This is the at least one. Anybody? I know all of these, that the sum is 1. I know the sum of all of those probabilities is 1. Were that stuck? It's the toughest one. I always consider this problem to be the toughest problem of probability, in my opinion. It's 1 minus the probability of all not male. Or in other words, all female. All failures, as we had used the word, slash, in this case, failures are female, because I'm looking for a male. I'm not saying females are failures. I'm just saying that we are looking to get at least a male in our selection, so not a male. So a success would be a male, and therefore a failure would be a female in that designation, which is not male. I could flip the script and say if I was looking for at least one female. Don't go saying that I call male females failures. Well, there's 4 of them, so this is 1 minus the probability that I get female, 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 female. So the probability of at least one male is 1 minus the probability of female, 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 female. Which is equal to 1 minus what? Let's calculate female, 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 female. It's kind of like we already did one that's very easy with the male and male. So what am I going to start off with?
11 over 17.
Boom. Times
10 over 16.
boom. Times
9 over 15.
boom. Times
8 over 14.
boom. Times 'That is it right there. Good job in not speaking up. I didn't even look up, and I don't even know who the voice was. But good work on that, and I was trying to trick you on that last one. There's only 4 selections, and we don't go to 7 out of 13. If it was 5 females, or at least 1 out of 5, we would have gone to 7. So we only go to 8 out of 14 as our final one. And then we just go to our calculator. So 1 minus parentheses 11 over 17 times 10 over 16 times 9 over 15 times 8 divided by 14. Enter. 0.86. 0.86. Pretty high, actually. That's pretty cool. You're making 4 selections. The probably like selecting a male was less than half, was less than 50%. It was really low, right? The probably selecting 1 male was as a fraction like 40%. But if I make 4 selections, the chance at least one of them is male is actually very high. It's 86% chance that out of 4 people I select, one of them is going to be a male. So in other words, if I didn't select a male, I would probably be like, well, there was an 86% chance of selecting them. Now, it doesn't mean that I can't select all females. And I've had that happen. You do something, right? It's happened probably in your classrooms or something you've done. And you're like, wow, or that's not fair. They just selected 4 females in a row. It's not random. Well, there was a 14% chance in the calculations that we selected all 4 being females. So there was a very high, that's pretty good. 4 females is 14% chance. And the chance that I get at least a male, at least one of them being male, is an 86% chance. So it's very likely that I get at least 1 male. That's it. Homework, I kind of kept the homework simple in terms of it's 2 problems, but of course there's A, B, C, Ds. Very similar to this type of problems that I've given you today. The toughest one, again, is the at least. And that's what I have for you for today. Take care. I will see you tomorrow.